Hello. Am I audible?
Yes, sir.
Okay, great. Okay. So, good evening to all of you.
Good evening, sir.
Uh, City session is going on right now, right?
Yes, sir.
So, it's about to finish or still it will have any idea?
No, sir, I left. So, no.
No, the session was about to finish. So, maybe we
Yes,
can
sir.
wait for some for a couple of minutes, then let's others will join and then we can start.
So
Okay, sir.
what will we be discussing today?
Uh, okay, so today we are going to discuss the mock, right? The time domain. There were two mock, right? Mock test one and mock test two, right? So we are
Yes,
going
sir.
to discuss the questions of mock test one. Okay. Meanwhile,
Okay,
how was the
so
mock?
Sir, numerical part is getting wrong as
So can
numerical
you
questions.
check or conceptual?
Concept or right service. Numerical part is becoming lengthy.
Maybe calculation mistake. No,
Yes,
see, here you it might maybe it's some kind of lengthy, but don't worry about during the examination. So there you will find very less calculation. Okay, it's not like too much calculation will be there.
the
The only
calculator
thing, uh,
provided.
yeah, there will be TCS scientific calculator. Okay,
Okay, sir.
yeah, in your system it will be there. So don't worry about calculation and all. There will be very less calculation. The only thing will check your concept. Okay, so you have to ready with your concept.
Okay,
Okay, so let's wait for we'll start from after 2 to 3 minutes. Okay, let's others join and we can start.
okay.
Yeah. Fine.
Sir, solution will be provided for today's session weekly that mock test.
Good evening, sir.
Hello. Okay, so let's start this session. Okay. So Livanshu is asking, so today's session is about mock discussion session. Okay, so we are going to discuss the mock test one. Okay.
Sir,
Uh,
PDF of mock test will be there, solution PDF.
no, it's not uploaded till now. After the end of the session, we will upload.
Okay, sir.
Okay. Once session will finish, we will upload. Okay. By tomorrow morning, you can get. Okay. Meanwhile, let's just discuss the question. Can you see my screen now?
Yes, sir.
Okay. Fine. Yeah. Okay. So what about the first question? How was it? Were you able to solve it? Yes, no, or didn't try?
Yes, sir, done first question.
First question, correct? Okay. So thing is, let's read the question carefully. Okay, so thing are, I mean, all the concepts are there. The only thing we have to identify the main thing. What are the things we have to calculate? Okay, if you see, question is the mean annual college fees paid by all the students in a college is 55 lakhs. Okay, it's about all. The mean annual college fees paid by male and female students of college are 40 lakhs and 60 lakhs respectively. Then we question is we have to find the percentage of male students studying in the college. Now, so we have to find the number of, I mean, percentage of male students. So what we will do? So let's say, so it's about question number one. So let's assume number of male students is N1. Okay, I can let, right? So let number of male students in college N1, right? So basically, we have to find the percentage for this N1. Now, then let number of female students, okay, in the college, let it's a N2. Okay, so far so good. Now, question is saying, okay, so mean annual college fees, okay, paid by male is 40 and female is 60 lakh. Okay, this is the something we have been given. So if mean is 40 lakhs for male, let's assume if N1 male is there, so can I say X1, X2 up to XN1? Let's assume these are the male students. Can I say or not? Okay. And let's
Yes, sir.
assume Y1, Y2 up to Y and 2. These are the female students,
Yes, sir.
right? I can say. Now, mean is given to us for male students as 40 lakhs. So if mean is given to us, that means, can I say what is mean? Summation of all the observations, right? Divide by N1, it's 40. Yes or no?
Yes, sir.
Correct? So this means, okay, this is given to us. Same for female is given to us is 60 lakh, right? So that means what is the mean summation of all the observations? That means I will say summation of I is equal to 1 to N2. Yi divide by N2 is 60 lakh. Yes or no?
Yes.
Yes, sir.
Correct. Now, one more thing is given to us. The mean annual college fees paid by all the students. All the students is including male and female. It's 55 lakh. That means, so I will say summation of I is equal to 1 to N1 xi plus summation of yi. Let's say I is equal to 1 to N2. Let's make it j for our simplicity. That means all are different. Divide by N1 plus N2 will be equal to 55. See, these are the summation of addition of all the male students plus addition of all the female students divided by total number of students, right? N1 plus
Yes,
N2. Yes or no?
yes, sir.
Correct. So, so basic thing is we have to find the value of N1 and N2. So we are going to use the all the information means from here, can I write summation of all xi's, right? N1 it's equal to 40 times of N1. Can I do or not? And similarly for this is 60 times N2. Any doubt? This step is okay for everyone?
Yes, sir.
Correct? Now, From here itself, from this step, if you see what I can find, summation of I is equal to 1 to n1, right? Xi, right? Plus summation of yi equal to 55 times n1 plus n2. Yes or no?
Sir, can you repeat again?
So this is something just a transformation I'm doing. So this is the numerator part. Can I transfer this n1 plus n2 as a right hand side?
Yes, sir.
Yes or no? Everyone is getting, right? Do let me know if you are not getting the things.
Sir,
Okay.
I'm not getting, please.
So this is the, okay. Is this clear? This step. This step is okay. If you have a by b is equal to 2, can I write a is equal to 2 times b?
Yes, sir.
Yes, sir, got it.
Got it? So this
Got
is
it.
something a, this is something b, right? So I can transfer this to the right hand side. Now it's clear? Okay. Now, so if you see, we have the values of this summation of xi. So let's make it equation number 1, equation number 2. So this is 40 times of n1, 60 times of n2. So this value I have, this is 40 times of n1 plus this value is 60 times of n2. Yes or no? Same, if you
Yes.
multiply, it will be 50 times, 55 times of n1 plus 55 times of n2. So let's do the some calculation. So can I do 60 times of n2 minus 55 times of n2 equal to 55 times of n1 minus 40 times of n1? Just a transformation of the terms, right? It will be 5 times of n2 equal to 15 times of n1, right? Are you
Yes, sir.
getting? Are you getting, right? So from here I got n2 as a 3 times of n1, right? So we have this information, right? N2 means I got the value of n2 as a 3 times of n1. Yes or no? Okay. Till this point,
Yes,
is it
sir.
clear? Is it clear, right?
Yes, sir.
Oh, fine. So if you see, question is asking about percentage of male students. So
Yes,
okay,
sir.
we know percentage of how you can calculate the percentage of male students.
N1 by total number
Okay,
of
so percent
students into
number of
100.
male students is n1, right? And
Yes,
total students will be n1 plus n2
N2.
into 100. That is something I can calculate the percentage, right?
Yes, sir.
Yes, sir.
So we have the value of n2 as 3 times of n1,
Yes, sir.
correct? So now if you
It's
see,
1 by
we'll
4.
get from here onwards, n1 plus, n1 divided by 4 n1 into 100. So here n1 will get cancelled out. You will get 100 divided by 4, which is nothing but 25%. Okay. So 25% is the correct answer. Is this clear to all of you?
Yes, sir.
So once can you show from the start?
Okay. Did you join late?
No, sir. I'll take a screenshot of it.
Don't worry, we'll upload the solution PDF. No need to take the.
Sir, please explain from starting. Actually, I joined late.
Okay, so had you attempted the question number 1 as correct or wrong?
Sir, it is my correct.
Then okay, then let's do the quickly.
Okay,
Okay.
okay, sir, got it. You can go.
Okay. So should I repeat? So suppose let's assume I mean it's a you
No,
do
sir, he said to go. He said to move to second question.
okay, let me repeat once. Those who have joined late. Okay. So thing is that let's go in the sequence. So suppose number of male students is n1, okay, and female students is n2. For example, if n1 male is there, so let's assume those male are x1, x2 up to n1 just for our simplicity, and similarly y1, y2, yn2 for female. Okay, so male mean for male students is given to as 40. So mean is nothing but like this. Okay, okay, summation of all the observation divided by number of observations is 40. If this is the case, then I can write summation of all the observation equal to 40 times of n1. Just a transformation of the terms. Same for female, it's given as summation of y, I mean mean is given to us 60 lakhs. So it will be summation of yi divided by n2. So it will be summation of yi equal to 60 n2, right? Just a transformation of this n2 multiplication of right hand side. One more information is given to us. Mean of all the students is 55. So all the students means including male, right? All the male and all the female students, right? Divide by n1 plus n2, because mean is something what? Summation of all the observation divided by number of observation. So total male is n1 and female is n2. So we have to add these two. So it will be 55. It's given to us. So from here I can say just transfer n1 plus n2 to right hand side. So I will get this quantity 55 times of n1 plus n2. We can multiply inside the bracket. We got this. Now summation of xi, summation of yi, we have the value 40 times of n1, 60 times of n2. So we can substitute the value here and we'll get this quantity n2 equal to 3n1. Now we know male students is n1. So how we can find the percentage? So percentage number of male students divided by total into 100. This is something I can calculate the percentage. Okay. So N2 we got, you can see as 3N1. So we can replace N2 as 3N1 and we got here N1 divided by 4N1. 1N1 will, I mean N1 will get cancelled out. So it will be 100 by 4, which is 25. Okay. So let's move to the question number 2. Question number 2 says by multiplying each of the numbers 4, 5, 7, 11, 13 by 4, then adding 7 to each of them, we obtain a new data set. What is the difference between sample variance of new data set and sample variance of old data set? Okay. So thing is that if you have observations of 4, 5, 7, 11, 13. So I have data set 4, 5, 7, 11 and 30, right? Okay. Let's assume the variance for this sample variance, right? It's asking for sample variance. Listen, right? So suppose sample variance, let's assume is S square. Okay. Now, for this data set, we don't know the value. Let's do in little bit. So what is the for question says we have to multiply it by 4 first, then add to 7, right? So if you multiply it by a 4, okay, then that means what you will get? Then new variance will be what?
E square S square.
Right?
S square.
So it will be 4 square into S square.
Right.
Yes or no?
Yes, sir.
And there it will be, it's saying we have to add 7. So we know there is no effect by adding a constant, right?
Right.
Correct. So far so good. So this is 16 S square. Question is we have to find the difference between sample variance of new data set and sample variance of old data set. So difference will be from here 16 S square minus S square. So this is the sample variance of new data set. This is old data set. So we'll get 15 S square. So basically we have to calculate the value of S square and I can substitute here and we'll get the answer. Yes or no?
Yes, sir.
Correct. So to calculate the S square, we know what is the formula 1 upon n minus 1 summation of I is equal to 1 to n xi minus x bar square. Okay. So let's calculate the x bar. X bar is what? It's a 4 plus 5 plus 7 plus 11 plus 13 divided by 5. So it's a 9 plus 7, 16, 27 and 13, 50 divided by, not 40 divided by 5, which is 8. Right? Correct?
Yes, sir.
Are you getting? So we have to do okay. So observations are, so we have to do basically 4 minus 8 square plus 5 minus 8 whole square plus 7 minus 8 whole square plus 11 minus 8 whole square plus 13 minus 8 whole square divided by 5 minus 1, right? So numerator part will be, I think it's 4. 4 square 16 plus 9 plus 1 plus 9 plus 25, right? Divided by 4. So it will be 9.
50 divided by 4, sir.
60 divided by 4.
60.
No, sir, 60. Yeah.
So 50 So 15 is the value of s square. So difference we got 15 s square. So it will be 15 into 15, which is nothing but 225. Okay. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
There a small question I wanted to ask there. Similar to the formula that like in the earlier session we told the population variance, we can also use the formula 1 by n summation of x square minus mean. So can we use that formula as well here with this sample variance as well?
No. Could you repeat? I did not get your point. Can you repeat?
So I was asking like the simplified form of the variance. One like population variance was 1 by n summation xi
Yeah. You can do it.
minus mean square.
See, anyway, that is the extension of that one, right? Sorry, expansion of
So we
that
can
one.
use it with the sample variance as well, right?
Yes,
Matlab n
you
minus
can use.
1.
You can use it's asking for sample variance, so you have to use the sample variance formula. You mean this expansion of these terms, right?
Yes, sir. So why I wanted to ask you, can we use the simplified formula?
Yeah, why not?
Right?
Yeah, you can use, no problem. Anyway, we will get the same answer.
Okay, sir.
Right? Yeah.
Thank you, sir.
So question number 3. So it says consider various variables that describes the specifications of the flats owned by a builder. These variables include price of flat, area of flat, BHK, right? Means bedrooms,
Hello,
one
sir.
hall and one kitchen.
Sir,
Yes.
sir, in last question, what's the role of that multiplication of 4?
What's the role of multiplication? That is the property we have to use, right? So question was, what will be the difference between new sample variance if you multiply it by 4 and you will add a constant. So there is no effect by adding a constant, right? If you multiply it by a
Yes,
constant, it will be square of that, okay? So your new variance will be 16 times of s square, okay? And old variance will be s square.
Okay,
Sir, will
okay, sir.
questions come on a
It will
similar
be
level in the
difference of 15s square. So
Yeah, difference is
well,
the difference. Okay? Difference
yeah,
is 15 s square.
yeah, that's why you can.
Okay, yeah. So it says then furnishing means furnished, semi-furnished, unfurnished, and locality. The builder owns 400 flats whose specifications are then organized in the data table. Okay, you have to organize based on the given information. We have to choose the correct option. Okay, first of all, tell me the number of variables in the data table is 5.
Yes, sir.
Right? We have 5 variables. First one is
Yes,
price,
sir.
area, furnishing 3, locality.
Locality,
I think
builder zone.
No. 1 second. Price is 1, area is 2, BHK is 3.
BHK is
Yeah,
3.
sorry,
Yeah.
furnishing is 4. Yeah, locality is 5. Yeah, we have 5. So first option is correct, right? Now the number of cases and observation in the data table is 5. Is this correct?
No.
No, sir.
Okay,
No,
why
sir,
not?
no. This
No,
is
sir.
Why not? It should be correct because
Sir, it
observation
should be
is
400.
400, right?
Yes, sir.
Okay, yeah, correct. Now, furnishing is a categorical variable. This is the correct, right? Because we can't perform any
yeah,
mathematical
yeah, sir.
operation, right?
Yes,
Yes,
sir.
sir.
And price of a flat is numerical variable, correct?
Yes, sir.
Yes, sir.
Sir.
Area of a flat is discrete variable.
No,
No, sir. It
No,
is
sir.
something
No, it is a
Continuous.
continuous.
Locality is a numerical variable.
No, sir.
No, sir.
Categorical.
Okay. Now you will be able to solve the questions related to week 1 and week 2 in quizzes. Don't worry. Okay. So question number 4 says the variance of a set of non-zero observations is 0. Then what we can conclude?
All observations are same.
All observations are same. Let me take one example. Variance of, okay, if suppose I'm saying I have observations 3, 3, 3, 3, 3. That means what? All observations are same. Their variance will be 0, right?
Yeah.
Okay. So that is the one of the example. Let me do the mathematically behind. I mean, what is the how we are getting the things? Okay. Suppose I have observations x1, x2 up to xn, right? All are non-zero observations. Okay. So tell me how we can define the variance? Let's do with the population variance. It's asking about variance. We can continue with anyone because we have to generalize the things here. So, how the population variance is defined? This is the case, right? Okay.
Yes, sir.
When it will be 0, let's do it. Let's equate it 0. If this is the case, so can I say summation of I is equal to 1 to n xi minus x bar whole square is 0? Yes or no?
Yes, sir.
Yes,
And
sir.
the above equation will be 0 only if xi minus x bar is 0.
Yes.
I mean, if
Yes,
all
sir.
square are
Obviously,
0,
sir.
correct?
Yeah, it's G.
If this is the case, then I can say this is the 0.
Yeah, both are equal.
Both are equal. Observations are equal
Yeah.
to the mean, right? That means when, and
Yeah.
this will be case. This means when all observations are same. That means all observations are
Same.
okay. Is this
Same.
clear?
Yes, sir.
Now let's move to the question number 5. So question number 5 says, okay, how many of you got this question as a correct?
Me, sir.
Yeah, sir.
Yes, sir, correct.
The previous question, please.
Okay, this one. Any doubt? Any doubt?
No, sir. Move to the next question.
Okay. So question number 5 says
The previous one. Sorry, my mic is not working.
this one.
No, the last one. Just we
one.
have solved. Yeah.
Hmm.
So how you just like equating both the thing same?
So, sir, 5, 0, 5, 10. If we take that set, we will get the mean as 5, right? But
Okay,
not all xi equals to 5.
Okay, first of all, see, this is the case, right? This is something we have
Right.
to do, correct?
Mhm.
Okay. If this is the 1 upon summation I is equal to 1 to x minus x bar square is 0, that means can I say this one? Summation of x minus x bar square is equal to 0, right?
Right.
When this equation will be 0, then all xi minus x bar square are 0.
Okay. Got it, sir. Got it.
Is this clear now?
Yeah.
Fine. Yeah. So, question number 5 is saying, first quartile is 80, third quartile is 100. So, which of the following must be true? Okay. So, Q1 is 80. Okay. Question number 5 is saying Q1 is 80 and Q3 is 100. Okay. So, you are asking about which option must be true. Okay. So, if this is the case, what are the options? So, like median will lie in the range 80 and 100. Median is
Yes,
90.
yes.
Standard deviation is at most 20. Okay. So if Q1,
Sir,
Q3 is
first
there,
option.
yeah, I will come. Don't. Okay. So if you plot the box plot, right? So here Q1 is there, right? Correct. Q3 is there. So median will be in between these two, right? Yes or no?
Yes, sir.
So median is, so first option is correct because median is will lie in the range 80 to 100. This is
Yeah.
the correct one. Okay.
Yes.
Let's verify the second. It says median is 90. So it's not always true. See, it's not
Yeah.
about median will be 90 itself. It's not, it's the middle value. It can be anywhere as per the data. Okay.
Yeah.
So median will be like in between. It's not exactly 90. Third is saying standard deviation is at most 20. Let's verify it. Okay. How will you verify the standard deviation is at most 20?
Root variance.
Root variance, you are telling me the definition of standard deviation. I'm asking, how will you verify it?
Sir, absolute deviation between the mean and a value or an observation
By taking the
must
lower
be
limit range
Okay.
80 and the upper limit
Okay,
100
okay,
or
okay.
equal to
Let's
20.
and then using the formula.
let's assume some random data. If Q1 is 80, right? And Q3 is 100. Okay. Let's assume this kind of data something. Let's assume this is a 50. Okay. For this data, Q1 will be 80. right? You can verify. N is 5. So P is equal to 0.25. So NP will be 5 into 0.25, which is 1.25. That is second observation. So Q1 is 80, right? Right?
Yes, sir.
Similarly, 5 into 0.75, right? So it's a 3.75. That means fourth observation, right? So which is 100. So Q3 is 100, right? So for this data, let's do the things. Okay, suppose this is the data set. Okay, for which this data set Q1 is 80, Q3 is 100. Okay, let's calculate the standard deviation. So what is the mean? To calculate the standard deviation, we need first of all mean. So mean will be 50 plus 80 plus 100 plus 100 plus 150 divided by 5, which is nothing but how much it will be? 350 plus 130 divided by 5. So 480 divided by 5. So it will
96.
be 96,
96.
right? X bar is the 96. Okay, let me use Excel for to avoid Google Sheet. So I took the observations 50, 80, 100, 100, 150, right? So if you see the standard deviation, right? Sample standard deviation, right? If you see say standard sample standard for this, so it's coming about out to be 36.46, right? Yes or no?
Yes, sir.
Okay.
Yes.
So thing is that it's not, so option number 3 is not true, right? Because it's asking about standard deviation is at most 20. But for this particular example, for this counter example, standard deviation is coming out to be 36.96, right? Yes or no? So it's
Yes,
not
sir.
true,
Yes.
correct? So option number 1, I mean, this one only will be correct. Is this clear?
Yes,
Yes,
sir.
sir.
But
Sir, one question.
how would we come to a conclusion that standard deviation is at most 20? Meaning, if without taking an example, how can we think of it? Is there a way?
No,
Because
see,
of insufficient data, can we conclude that we
no,
cannot say
because
this
of
thing?
not, okay, it's not about insufficient data. See, you have been given, it's okay. So the question says, if for a data set, suppose Q1 is
Right.
100, 80 and Q3 is
Mhm.
100, right? So
Mhm.
for that data set, is saying if Q1 is 80, Q3 is 100, then it's saying standard deviation will be at most 20. Okay, that
Mhm.
is the case. So to
Right.
disprove something, we need only one counter example. Yes or no?
Okay.
Okay.
So
So
we have to go through this process.
correct. So if you see for this particular data set, I took this data set. For this data set, Q1 is 80, Q3 is 100. Okay.
Mhm.
For this data set, I calculated sample standard deviation, or you can calculate population also. It's not mentioned here. So I got 36.96. While in the option is saying it should be at most 20. So that is the wrong. Got it?
Okay, sir.
Okay. So next question is the correlation coefficient between two variables x and y is 0.45. Okay. What will be the new correlation coefficient if 0.10 is added to all the values of x variable and every value of the y variable is doubled and two variables are interchanged? Did you get the meaning? What is the question?
Yes, sir.
So question number 6 is saying correlation between x comma y is 0.45, right? Okay, so there is one property. What is called, suppose R, I mean correlation coefficient between two pairs of observation is, suppose this is R. Okay, correlation coefficient. If this is the R, I mean just let's generalize this. And if we are going to do A plus B times of xi and C plus D times of yi, this will be same as R. Would you agree? So there is one condition provided that B and D have the same sign. It should be same sign actually. Okay. This is the one property you can keep in your mind. See, one thing is there, you can also calculate by the formula itself. Okay. So why I'm going to use this property? Let me verify this. Okay, let me verify this. if this is the correlation between a plus bxi, comma c plus dyi is there, so this will be covariance between, okay, a plus bxi, comma c plus dyi, right? Yes or no? Then standard deviation of a plus bxi into standard deviation of c plus dyi. This is something correlation is defined.
Yes, sir.
Are you getting?
Yes, sir.
Now, if covariance is there in the numerator part, if you see, so what we'll get? We'll get b times d into covariance of xi comma yi. See, if you have
Yes, sir.
covariance of
Yes, sir. Yes,
a
sir.
plus bxi, right, comma c plus dyi means what? You have to do, let's say 1 upon n summation of xi minus x bar, right? Okay, are you getting what I'm trying to say here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so it will be x. Okay, normal covariance is defined 1 upon n xi minus x bar yi minus y bar, right? This is summation sign.
Right.
So xi
Yes.
means observation minus mean. So here observation is what? A plus bxi. Okay, minus mean will be what? Minus a minus bxi.
Yes, sir.
Sorry,
Yeah,
minus
yeah.
mean means
X
it will be x
bar.
bar. A will get cancel out.
Yeah.
I will be having bxi minus bx bar, right?
Yeah.
Yes,
For
sir.
this, it will be
Yes,
d yi minus d bar, dy bar, right? So b and d will be outside the bracket. That is something I have done. Is this clear?
Yeah.
Sir.
Yes, sir.
So can you explain it once more?
Okay. So the one thing I'm using the property itself here. So if you see for this covariance, how covariance is defined. Okay. So if you are not getting the things at any point, right, you can ask at the same time. Because I have erased the things. No problem. Okay, so it's 1 by n summation of xi minus x bar yi minus y bar. This is something covariance is defined for xi comma yi, right? So
Yes, sir.
covariance between, let's say, a plus bxi comma c plus dyi, it will be 1 upon n summation of, instead of xi I have a plus bxi, right? So I
Yes, sir.
can do a plus bxi minus x bar means mean of this observation. So what will be mean of this? It will be a plus bx bar.
Yes, sir.
So a will get cancel out.
Yes, sir.
Correct. So you will be having 1 upon n summation of bxi minus bx bar. Similarly, dy minus dy bar. So from here, I can take b and d outside. I will be having 1 upon n summation of xi minus x bar into yi minus y bar. It will be b times d, which is nothing but again covariance of xi comma yi, right?
Yes, sir.
The same thing I have done. Okay.
Got it, sir.
So let me do from the next page from here onwards. Okay, from next page. Okay. Okay. So I had correlation. I have to calculate the correlation a plus bxi. So I'm generalizing it to know the property. Okay, so that you can use the property directly itself. You can do the y formula also. Not a problem. You will get the anyway same answer. So it's a standard deviation of a plus bxi into standard deviation of c plus dyi, right? So in the numerator part, I got b times d covariance of xi comma yi, right? In the denominator part, can you tell me there will not be any effect of addition of constant, right?
Yes, sir. It will become
Yes,
d
sir.
of
So I
standard
will get,
deviation of
yeah,
xi.
I will get b times of standard deviation of xi into d times of standard deviation of yi, right? So this b and d will get cancelled out. I will be having covariance of xi comma yi divided by standard deviation of xi. Standard deviation of yi, yes or no?
Yes.
Right? So
Yes.
this is same
Yes,
as
sir.
correlation of xi comma yi, which is r.
Yes.
Now is this clear?
Yes, sir.
Correct?
Yes.
So what is the property? What is the question says? Question says 0.10 is added to all the values of x variable and every values of y variable is doubled. So correlation of, there is 0.10 has been added to all the xi and that is c 0 here and 2 times of yi, right? This is something in the question is given to us. Yes or no?
Yes, sir.
So by this property, if you see this one, this and this is the same as correlation of xi comma y, which is r, and this is given as 0.45. So
Sir,
this will
and
be,
then variables are reversed. They're interchanged.
so there will not be any effect. See, covariance of x comma y is the same as covariance of y comma x or correlation.
Okay.
Okay, these are the same. If you interchange also, there will not be. Okay, is this clear? Fine for everyone?
Yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
Now, so question number 7. Let's move to question number 7. It says the bar chart given in figure Q.1 shows the shoe sizes of a group of 70 children. Based on the information, we have to find which options are correct. Okay. First is saying 16 children wear a size 8 shoe. This is the correct, right? Because for 8 on the x-axis, you can see it's a shoe size is given to us. Y-axis is number of children. So for the bar of the 8, shoe size, size 8, 16 people are there, right? So first option is correct. Yes or no?
Yes, sir.
Now,
Yes, sir.
option number B is saying 29 children wear a shoe size less than 8. So less than 8 means we have to count the number of shoe size 5, then 6, then 7, right? So it's a 25 plus 20 plus 9, which is 54, right? It's not 29. That means option B is incorrect.
Yes, sir.
Yes, sir.
Correct? Now, next is 7 is the median shoe size. Let's do. So how will you compute the median? First of all, to calculate the median, we have to consider the middle observation something, right? It's asking about 7. So if you see, we have shoe size 5. How many children are there? 9, right? Shoe size 6, 20 are there, right? And shoe size 7, 25. And shoe size of 8, 16 are there, right? Yes or no?
Yes, sir.
Yes, sir.
So if you add all the observations, how much is there? Totally 70, right? Right? So median is what? Median is middle observation, right? Something. See, for okay, tell me for if there is 70 observation, what will the median? First of all, median will be average of 35th and 36th observation or not?
Yes, sir.
Yes, sir.
Yes, sir.
Are you getting my point? Because this means 5 is occurring 9 times, right? This means 6
Yes,
is
sir.
occurring 20 times. 7 is occurring some 25 times, right? This is the meaning of the data. Are you agree with me?
Yes, sir.
Yeah.
Now, so median
Yes,
is,
sir.
okay, so you can see 70 is there. So median will be average of 35th and 36th. Two size.
Yes, sir.
Yes, yes.
Now, so what is the where 35th and 36th will be there? So see, you can see 29 observations are there itself, right? 9 plus 2.
Yes, sir.
Then 35th and 36th will be here.
7th.
7th, right?
Yes.
So 7
Yes,
will be
7.
median. Yes or no?
Yes.
Yes, sir.
Yes.
So 7 is the median shoe size, which is correct option, right? I think it should be correct. Yeah, 7 is the correct. Now next option is saying 35 children wear a shoe size larger than 6. So larger than 6, you can see for 7 and 8, there are 25 plus 16, which is 41. So this is the incorrect. Okay. Next one is 6 is
Yes,
the
sir.
mod size, right? Mod shoe size. No, this is 7 is the mod shoe size, right?
No,
Yes, sir.
sir. 7.
Okay. Yeah. Range of the shoe size is 4. Is this correct?
No.
So what is the range? Range is
Maximum minus minimum
12
observation.
minus
range
16.
is 3 here, right? 8 minus 5. Okay. It says
Yes.
value of first quartile for shoe size is 6. So we have to find this one. Okay. So let's do this. So how much n is there? 70. First quartile means P will be 0.25. If you calculate n into P, that means 70 into 0.25. What you will get? 25
16, 1.65.
17.5, right?
Yes, sir.
Okay. That means 18th observation, right? So where will be 18th observation? 18th observation will be in this 6 one, right?
Yes, sir.
Yes.
Correct. So that means I mean your Q1 is 6, right? 6 size. Okay. Is this clear?
Yes, sir.
Yes,
So
sir.
this one is the correct. Okay. Now,
Hello, sir.
yes.
Sorry to disturb you, sir. Sir, actually, I'm not able to attend this complete Zoom session. So, sir, could you please solve the question number 12 and 13 of mock test 2? At the end of this, after this, I can watch on YouTube.
Okay, okay. We'll try to solve it. If not possible, okay. Then don't worry, we will upload the solution PDF. Okay.
Okay, sir. If it is possible, I text the question in the chat box. You can solve
Okay.
at the end. I can watch on YouTube. Okay, sir.
Okay, okay. Okay, fine.
Thank you, sir. Thank you.
Yeah, thanks. Okay. So next question is saying the stem and leaf diagram is given to you, figure Q.2 and figure Q.3. Okay, you can see key is given to you. 30 means 30, 4/3 means 43 marks. Okay, in English and computational thinking. So question says there is okay in Q.3 1x is there. What is the difference of the model score of computational thinking and CT? Okay, first of all, tell me how will you proceed? See, model means how? Okay, in the first diagram, what is the mod? Which observation occurs more frequently?
59.
88.
88.
88, right?
88.
80 is the 2 times, right? So for English, 88 is the
Mode.
so for English, okay, mod is 88, right? For CT, tell me what will the mod?
59.
Yes, sir. For CT mode is 88.
Oh, sorry, yeah. For CT mod is 88. So it should be CT, and for English mod is 59, right?
59.
Okay,
Yeah, right.
one unknown value is there, but as of now there is no need to calculate. Why?
It is not the mod,
Because
means it is
yeah,
not
it will
modes.
not be anyhow mod. Okay,
Yeah.
now fine. So it is asking about model score, difference between model score. So what will be the difference? It's a very simple thing. Sir. Difference will be 88 minus 59, which is 29, right?
29. Yeah.
This is the correct 29. Now, if the range of computational thinking scores is greater than range of English score by 7, then what is the value of X? First of all, what is the range in the CT? So if you see, so range is what? Maximum minus minimum, right?
Yeah.
So in CT,
88 minus 30.
okay. So in CT, maximum is
88.
88. Very good. And
Minus
minimum
30.
is 30, right? So what will the range? We know range is nothing but max minus minimum. 88 minus 30, which is nothing but 58, right? What is the next thing is saying? Range of computational thinking scores is greater than range of English score by 7. First of all, we have to find the range of English. Okay. So range of English, we don't know, right? I mean, we can't find the exact. Okay. First of all, in English, okay. So what is the maximum? Maximum will be X, right? Minimum will be
9x.
9x, sir.
Yeah, 9.
Yeah, 10th and unit digit both.
So we assume that x is greater than 0. Then we could use that.
1 second. 9x 1 is
No,
9.
no, sir.
Yes.
Only. Sir, we can take x as unit digit. Then we can write number as 9x.
Don't worry. Let's write down as a max itself. Okay. Minimum is 43, right?
43.
So what will the range?
Yeah.
So I'm
Yes,
writing
sir.
RE for
Okay.
range of English. So it will be max minus 43, right? Okay. And
Yeah.
let's write RC for range of CT. Okay.
So
Okay.
one quick doubt: why are we not taking max for English?
It's a known. X is a known to us.
Oh, okay.
Okay. Yeah. So that is we have to find. So it says range of CT is greater than range of English by 7. By 7 means what?
Difference is equal to 7.
Yeah.
Difference is equal to 7, right? So that means the range of English, okay.
So CT is more, English is less.
See.
But
CT.
RC
Yeah,
RC
go
plus
ahead.
7 RC plus 7 is equal to max minus 43. No.
See.
RC minus 7 is.
One second. See, just read the statement carefully. It says range of CT is greater than range of English. See, range of English we don't know, right? If range of CT is greater than 7, that means range of English should be 51 or not?
Yeah.
Or we can say 58 equals to max minus 43 plus 7.
Yeah,
Same.
that is same.
Yeah.
Okay.
Exactly.
So I'm just doing. See, I'm saying range of computational thinking is more than
7 more than.
English. So English, then it will be minus 7. Then I can find the range of English, right?
Directly 51.
So it's a max minus
51 plus 40.
So here max is what? 51
94.
plus 43, 94. If maximum is 94, so if you see from the stem and leaf plot, so x should be 4, right?
Yeah.
Only then it will be 94. Yes or no?
Yes, sir.
Yes, sir.
So value of x should be 4. Okay. Fine. Is this clear?
Yeah.
Okay. Now next is what is the difference between the medians of two scores? We have to find the medians of both. So if you see what is the median, first of all, let's count whether odd observations are there or even. So 2, 4, 6, 5, 11 for 4, 15, 3, 18. 22 is there. Okay. So 22 means we have to take the average of 11 and 12th observation.
11th
right?
and 12th, yes.
So what is the 11th observation? 11 is 59, right? 12th is 62. Yes or no? In the CT statement plot, everyone is getting.
Yes.
So we have to take the average of median for CT will be 59. I mean average of 11th observation plus 12th observation, that is, so 59 plus 62 divided by 2. Okay, which will be 9, 2, 11, 6, 5, 12. Which is nothing but
60. Yeah, 60.5.
Okay. Same median for English. Okay. So here I think again 2,
18
5,
observation.
7 for 11, 2, 13. Yeah, 18 observations there. So 18 observations there. That means we have to take the average of 9th and 10th. Yes or no?
Yeah.
Divided by 2. Yeah.
So 9th observation is 65 and 10th is 67. Okay, everyone is getting right. See, here there is no need to
Yes, sir.
arrange the data in ascending order in stem and leaf because it's already in ascending manner. Okay.
Yeah.
So it will be 65 plus 67. So median will be 65 plus 67 by 2, which is nothing but
66.
yeah, 66 directly. Correct. Okay. So we have to find the difference. So difference will be 66 minus 60.5, which is 5.5. Is this clear?
5.5.
Yeah. Yes.
Yes, sir.
Now, let's come to the question 11, 12, 13 and 14. Okay. So, the question says, I mean, there is one table is given to it. It's the placement data set, okay, for computer science engineering and information technology. So very first question is which of the following is are cases? You know case. First of all, row represents the cases, right? Okay.
Yes.
And it should be unique. So you can say IT18B001. Okay. So it will be case, right? Because it's a unique also. Yes
Yeah.
or no? So
Yeah.
IT18B001. Yeah, it's the correct option. Then M will be case. No,
No.
right? Okay, because it's first of all it's
It's
not
repeating.
unique. Yeah, it's a repeating.
Yeah.
Okay. Then F will not be a case. Okay. Similarly, tell me CS18B005 will be case because it's a case. right?
Yes. Yes.
Because you can say
Of
this
course.
row. This row. Can you see
Yeah.
my the cursor? Okay, this row.
Yeah. 75%.
Yeah.
Score.
So IT18B009. So I think there is
It's
no
yeah. It is
value, right?
absent from the
I see
table.
absent. Yeah. CSC is not a row or it's not basically it's not case and observation because first of all row represent the cases and it's not unique also. Okay.
Yeah.
Same IT also. Okay. So is this clear or in doubt?
Yes, I clear.
Clear, sir.
Next is which of the following
Clear, sir.
is our numerical variable? Tell me, numerical variable are which one? Salary and score percentage, right?
4%. Yes.
Rest
Yeah.
are the which we can't perform any mathematical operation, right?
Yes, sir.
Yeah.
Next one is what is the population standard deviation of the salary in INR lakhs of the placed student? Ignore the cases of students who are not placed. That means we have to calculate the population standard deviation of these observations only. 8.504, 4345, right? Okay, so
Okay.
I'm going to do on Google Sheet. Will that be all right? Okay, let's.
Yes, sir.
Yes.
Yeah. Sir, but one question here.
Yeah.
So we will not count not placed as a number of observation, isn't it?
Yes. It's clearly mentioned, right? That's all.
Yeah.
We have
So
to
we
ignore.
delete. So we delete the whole row.
Correct. We have to ignore.
Okay.
Okay. Anyone can tell me the observation? This 8.5 and 4, 3.
Yes.
8.5, 4,
4,
3.
3. Again 4.
4. Okay.
5.
5. Okay.
7.
Okay.
3.
Okay.
14.
Okay.
3.5.
Okay.
10.
Okay.
And lastly 4.
Okay. Okay, let me clarify one thing. This Google Sheet and all will not be available during the quizzes. Okay, this is something you have to do with the help of pen and paper. Here I'm doing just to for the time and all. Okay, so
Yes.
Yeah.
okay, don't okay, and don't worry about the calculation part also. There will be observations on which you can perform the calculation in an easy manner. Not too much calculation will be there, as you have seen in practice assignment and graded assignment. That is something for your practice, but as a exam point of view, don't worry about too much calculation. If there is calculation, numbers will be very, in a, what you can say, in a easy number will be there where you
Easy
can perform the
numbers. Yeah.
calculation. Okay. So it's asking for population standard deviation, right? So we can, if you see, wow, what are we able to? So 3.36 is the answer. Okay. So 3.36, yeah, it should be it's in the range. Okay. So basically, how you can calculate the population standard deviation is nothing but sigma square, right? It's assuming standard deviation, it will be square root of 1 upon n summation of I to n xi minus x bar whole
X
square.
bar
So
square.
what you have to do, the all observations, right? Here it's all observations there. So how you can compute 8.544 and also you have to subtract the mean, right? Let's do like this. So what is the average of this one? So average of this all observations will be 6, right? So
6.
we have to do 8.5 minus 6, right? Square, okay? So 6 we have to, let's make it fix here. Okay.
Fix it.
Okay.
Okay.
So and what we are doing at the end, we are adding squares of these all things, right? Okay.
Yeah.
We have to add these things, these all things. To calculate the sample, we have to divide by how many observations are there? 11, right?
11.
That means we have to divide by 10, right? Correct? Since it's a standard
Yes, sir.
deviation, then we have to take the square root of, so square root of this observation is the 3.52. Why is that?
So you have just calculated sample, and in the question
Oh,
we
it's a population. Okay, sorry. So it should be
to
11.
divide by
Yeah, so you
11.
can see that these values are the same. Okay.
Yeah.
Fine.
Okay.
Okay. Now, next is okay. Is this clear, right? You are getting just a calculation of that. Okay.
Yes, sir.
Okay. Now, question is, what is the absolute value of point biserial correlation coefficient of association between gender and salary? So we have to do this gender and salary. Okay. Can you tell me these things? Gender and salary for male, and what is this? Anyone can tell me? Just,
Yes, sir. Firstly, for males.
yeah. So first gender, okay, then salary. Okay, let me. Okay, so just tell me the value of gender and respective salary. Okay, gender is
Male.
Male. Okay.
8.5.
Okay.
Male 4.
Male 4. Okay.
Female 3.
Female 3. Okay.
Female 4.
Female 4.
Female 5.
Female 5. Okay.
Female 7.
Female 7.
Female 3.
Female 3.
Male 14.
Male 14.
Male 3.5.
Okay.
Male 10.
Okay.
And lastly, female 4.
Female 4. Okay. So to calculate the point biserial, now you can say point biserial we are using to find the association between a categorical variable and a numerical variable. So here gender is a categorical variable which has two categories, and salary is the numerical variable. So point biserial is defined as y bar naught minus y bar 1 divided by sigma x into square root of p naught into p1. As I have mentioned in the revision session also. So here, if you are using this form, this form, I mean,
Population
formula of this
variance.
form, so it should be population standard deviation. Okay. In the
Yeah.
lecture video, if by mistake it's a small sx, so it should be sigma x. Okay. Now, so what is the okay? First of all, y naught and y1. So this is something I have to code with. Let's make it male as 0. Okay, and I can code female as 1. Right. You can do in vice versa also, not a problem. Anyway, we are going to calculate the absolute value. Okay.
Yes, sir. Sir, in the formula, can we use this sample standard deviation?
Yeah, we can use simple standard deviation, but not for this form. Okay, you can't say this. Okay, let me. You can't say this one is the both one is the correct. Okay, you can't say this both are same. Okay, why? Because sigma x you can replace with this sigma x with this value. I think I have done the derivation. Maybe not.
Yes, sir. I have missed that lecture.
Okay, you should rewatch. See,
Yes,
you know
sir.
this form, right? Okay.
Yes, sir. Yes.
So
Yeah.
sigma square will be n minus 1 divided by n s square, right? So sigma I can write square root of n minus 1 divided by n into s. So
Yes,
this sigma I have to replace with this value, not with sx. Okay.
Okay.
This total
So
quantity we have to replace.
yeah. So point biserial is defined for population, and if we want to use the sample, we have to
Then
make
you have
this.
to use this quantity. Okay. So
Okay,
if you are,
okay.
so it's a good to it's advisable just use this form for simplicity, right? Rather than adding some
Yes, sir.
extra.
It will be.
Okay. Now.
Yeah.
So let's do this P naught. Okay, so what is P naught? P naught is N naught divided by N, right? So we have to find the proportion which are coded with 0. Okay, so that means what? How many objects are coded with 0? 1, 2, 3, 4, 5.
6 objects.
5, right?
Oh, sorry, you have
5 divided by 11, right? Yes or no?
Yes,
Okay.
yes.
And P1 is then it will be 6, right? 1, 2,
6
3,
objects.
4, 5, 6 by 11, right? Now, so y bar naught is what? We have to calculate the mean of those observations which are coded with the 0. That means you have to calculate the mean of 8.5, 4,
male,
14, 3.5, 10, and that's all. So we have to 8.54 plus 4 plus 14 plus 3.5
10
plus 10
divided by
divided by 5. Whatever value
5.
we'll get. Okay. We are
Yeah.
not. Should I solve it or it's fine? Are you getting the idea?
Okay,
Sir,
okay,
eight,
sir.
eight.
You can solve.
8 is there? Okay, great.
Yes,
Yeah.
sir.
So y bar 1 will be, we have to calculate the mean of those options which are coded with 1. That means 3 plus 4 plus 5 plus 7 plus 3.
4.34, sir.
3 plus 4 plus
Yeah,
5
yeah.
plus 7 plus 3 plus this 4. Divide by 6. Okay. How much?
4.34.
4.33.
4.33. Okay.
Yeah, 333.
And sigma x we have to calculate for these all data set, right? And we
Yeah.
have calculated, right? Just a few minutes before, I think. What was
Yes, yes.
3.36 something, right?
Yes, sir.
So
364.
Yes, yes,
RPB will
yes.
be this minus this. So 8 minus 4.33 divided by 3.36 square root of 5 by 11 is how much? I think it should be 0.4 something, right? 0.45. Okay. And 6 by 11
Yeah,
should be
4.5.
0.5.
Sir, we can directly take 30 by 11. No?
Yeah, same.
Yeah, anyway. So just calculate this, you will get the answer for this one. Okay.
Oh,
Yes, sir.
Now, is this clear, right?
yes.
Sir, could you explain one more time that sigma x, x1?
So sigma x is what? We have to calculate the population standard deviation of these all values, right? Okay.
That formula, what you said,
This
under
one.
root and minus. Yeah.
Okay, don't worry about this formula. See, I think I don't remember the name. So main question is if you are using the formula this form, so one correction is there. So by mistake in the lecture video is a small sx, right? So it's that doesn't mean it's a sample standard deviation. Okay, we have to use the population standard deviation. If you are going to use this form, if we are interested to
Yeah.
like suppose you want to use the sample standard deviation, then this sigma x you can replace with square root of n minus 1 divided by n into sx. Okay.
Okay, then basically means that sigma x is equals to the sigma of that formula one, na?
Square root of n minus 1 n divided into
Yeah,
sx.
yeah.
You have
Yes.
to replace this sigma x by this quantity if you want to use the small s. Okay. So it's better to
Oh,
use direct population standard deviation, right?
yes,
Standard,
always.
standard
Okay.
deviation of
Would we
population.
ever have to use SX, meaning, would we have to ever get a SX, meaning a sample point by
Sample, yeah.
relation?
No, it's not about. No,
there is
it's not
nothing like
about.
that.
It's not like
Okay.
a sample point by correlation and all.
Okay,
It's
so
about
if we
correlation.
already have sample standard deviation, then we can use this formula instead of driving the population again.
Correct.
That's what.
You can do.
Okay,
Okay. The only thing is, if you data set is given to you, so it's preferable to use the previous. I mean the sigma x one.
Right.
Because it's a little bit. I mean, rather than SS doing then square root of multiplying n minus 1 by n, it's good to go with that.
Sir, your battery is.
Oh yeah. Thanks for that. Just give me 1 minute. Let me connect with the charger.
While sir is connecting the battery, my co learners. So when there is a range, right, there are two answers. So do we have to write the both or one is enough?
Two answers.
Any number in between the range or including them.
Okay, including them will be treated as the correct answer.
Yes.
Yeah.
Anything else?
No, good, thanks.
Hello, am I audible?
Yeah.
Okay, great. Okay, so can we move to the next part?
Yes,
Yes,
sir.
sir.
Yeah. So next question is saying annual donation to a non-profitable organization is given in this table where some data is missing and all. The donation given by company B is 5 crore rupees more than company D. Okay, and which are missing. How much did company D donate to the organization? Okay, so first of all, to calculate that one for the company D, okay, let's assume for company D donation is X and company B it will be X plus 5,
Yes, yes.
correct? Because it's more than
Yes, sir.
5 crore, right?
More than 5 crore.
Correct. So let's do the question number 15. So let for company D, if X amount is X, right? Donation is X, then for B it will be X plus 5, right?
Yes, sir.
Yeah.
Now, we have to find the value of X. To find the value of X, first of all, you know what is the things, then can I say, sum of all the frequency, right? 56, right? Plus X plus 5 plus 45, right? Plus X plus 16. So this is something equal to total donation, yes or no?
Yes,
Yes,
sir.
yeah.
Correct.
Total
But how
donation.
we can find the total donation? We know
Here
relative frequency is equal to frequency divided by total observation,
Total.
Yeah.
correct?
Yeah.
So from
Yeah.
here I can find total. So total will be what? Frequency divided by relative frequency,
Yes, sir.
Yeah.
correct? And what is the frequency? We can use any one. Let's do this 44 one. So it will be 45
45.
divided by 0.225.
Yeah.
That can you calculate 45 divided by
200.
200? Fine.
In just
yes,
So
half.
that means total
Yeah.
donation is 200, right? So that means this 56 plus x plus 5 plus 45 plus x plus 16 will be 200, right?
Yes, sir.
Yeah.
Correct. So that means 2x plus 56 plus 5, that 45 plus
61.
50,
61, 45.
122.
106.
122.
Oh, yeah.
Yeah.
122.
So here 2x will be 200 minus 122, which is nothing but 78.
78.
Correct.
Yes.
So x will be 78 divided by 2, which is nothing but 30,
39.
which is the answer. Okay. Is
Yes.
this
Oh,
clear?
Yeah.
No. So next question is histogram of runs scored by a batsman in his career. Okay. It says
Sir,
in his career is I mean, all the
hello.
things in yeah.
Sir, how do we know both the X are same? Like how?
Both x are same means.
Yes, sir. In this B and D are unknown. So we took X. How do we know that both are X only? Maybe there is X and other one is B.
Okay, what is this?
Even in pipeline,
Here
so the
there is
question is, how
condition.
do we know that B and D has the same donation amount?
Okay, first of all, can you read this statement and tell me whether both are same or not?
5 times more than of that.
5 times more than
Same.
other one is
Right. And what I have written? I have written same or I have written x plus 5.
X plus 5. Yes, sir.
Yes, sir. Okay. Okay.
Now is this clear? Okay.
Yes, sir.
So
Yes.
we can let for company D donation is x. Then for company B it will be x plus 5, right?
Okay.
So read the statement carefully. So that will otherwise see sometimes in hurry we are making the mistake. So that is something we should avoid. Okay, due to minor mistake we can get the incorrect answer. Okay, no worries.
Yeah.
So it's given to us here. So for intervals, okay, there are values, right? Okay. I mean, we have to calculate the approximate mean actually. So can you tell me for 5 to 15, just tell me the observation for 5 to 15 is 1, right? Then 15
Yeah.
to 25, it's the,
Three.
I mean, it's
Three.
not
3.
1. I think it should be,
Yeah, it's 1.
It is, yeah,
yeah, it's
approximately.
1. Yeah, frequency is 1. Yeah,
Yeah.
sorry. Okay, so question number 3. Okay. So what is the interval, right? Class interval. So
Yes, sir,
class,
we can use directly class mark here.
yeah, we can use, but let's do in.
Okay.
And what is the xi? That is the midpoint, right? And then
Yeah.
fi. Okay. Just tell me, for 5 to 15, what is the frequency? Is 1, right?
Yeah.
Then 15 to
25.
how much?
It's 3.
3.
Okay, then 25 to
25. 35.
it's how much?
4.
4. Then 35 to
35 to 45. 4.
4 again. Okay. Then
45 to 55. 3.
3. Okay. 55 to
55
65,
to
right?
65.
How much?
4. 4.
Then 65 to 75.
75. 1.
How much? 1. Okay. Then 75 to
75 to 85.
is
2.
2. 85 to
95. Again 2.
okay. 95 to I think 105, right?
105.
How much?
1.
Okay, fine.
1.
So we have to calculate the class mark, means average of these two intervals. Okay. So class mark will be 15 plus 5 divided by 2. That means 10, right?
Yeah.
Same for
Exact
20.
middle
It's
point.
the middle
Yeah,
point. So
20, 30,
30,
40, yeah.
40, 50, 60. It will be 70. It will be 80. It will be 90. Then 100.
100.
And we know if xi and fi is given to us, then how we can calculate the mean is nothing but summation of fi into xi divided by summation of
Sigma
fi.
fi.
So we have to calculate the fi into xi. That is 10, 60, 120, 160, 150, 240, 70, 160, 180, and 100. Now we have to calculate the. There are some background. Vikram, could you please? Yeah, you can unmute.
Sir,
whenever
it's
you
not
want.
from my mic.
Yeah, sorry. It was...
Yeah, no problem. Yeah. So we have to add this and the frequency. Okay, so frequency is how much? 4, 4, 6, 10, 15, 17, 18. 4, 4, 6. Sorry, 8, 4. 12.
25. So exactly.
5. 20, yeah, 25, right? And the addition of these two, 60, 70, right? Then 120, 190, 190, 160, 350, 1250, right?
Yes.
Can you
Yeah.
cross check? Cross check, yeah. So x bar will be 1250 divided by 25, which is nothing but 50, right? 50 is the answer. Yeah.
50.
Answer.
Yeah.
Now, next question is, what is the approximate population standard deviation of the runs scored by batsmen? So, you know, population standardization, I'm not going, will do the whole calculation. I will tell you how to do this. You know, population standardization defined how is defined as 1 upon n summation of I equal to 1 to n xi minus x bar whole square. If frequency is given to you, that means it will be 1 upon, it will be summation fi, total observation, right? Summation I to n. Actually, this n will be same as summation of fi. That is something.
Yes, sir.
And multiplication of fi. That's all. Okay. So what we have to do? We know the frequency. Mean. So what we'll do? Xi minus here. We'll do xi minus x bar. This means 10 minus 50 square into fi. That means into 1. Right? Then 3 into 20 minus 50 whole square. Right? Similarly, 4 into 30 minus 50 whole square. Are you getting? Right? Same.
Yes,
4 into 40 minus 50 whole square. Same manner we have to do, and then at the end we have to add this value, and then we can do, let's say this is coming out to be, let's say some
Sir,
y.
144.
Suppose y is y.
Sir, here.
Yeah.
One problem, one doubt. Sir, fi is not multiplied in the side, like whole square.
No. It's not inside. It should be outside, right?
Yeah.
It will be outside.
It's outside.
Okay.
Okay. So suppose summation is coming out to be y. For example, just suppose this is the y. Okay. Then sigma square will be y divided by 25. So whatever y will be there, you can calculate the answer. Okay.
Take the root of that.
Yeah. So it's a
Yeah.
variance actually. Whenever standard
Yeah.
deviation, it will be a square root of this value. It's basically square
Yeah.
root of y divided by 25. Okay.
5. Yeah.
Fine. Is that clear?
Yeah.
Yeah.
So next question, I think this is the last question. Okay. So this question says, in a call center, there are 75 employees and number of calls they receive vary over the length of a day. Now, the working hours are 9 a.m. to 6 p.m. with lunch break from 1 p.m. to 2 p.m. That means working hours is okay 9 a.m. to 6 p.m. Question number 18. Working 9 a.m. to 6 p.m. right? With lunch break, right? From 1 p.m. to 2 p.m. Okay, that is the information we have given as of now. Now, the average number of calls received from 9 a.m. to 1 p.m. by an employee is 15 per hour. Okay. Okay, if this is the case and the average number of calls received by the employee from 2 p.m. to 6 p.m. 5 per hour based on this data. Okay. The average number of calls received by employee in working hours 10 calls per hour. Okay, let's do.
No, sir, it's 9 hours.
I mean,
I think.
we have to verify. I'm not saying it's
Okay.
so let's do. It's saying 9 a.m. to 1 p.m. is 15 per hour, right? So if 9 a.m. to 1 p.m., right? How much cost is there? 15 calls,
15
right?
multiplied by 4.
15 calls per hour. So in this between, how much hour is there? 4 hours, right?
4 hours. Yeah.
So that means there will be how much total?
60.
Okay, total calls between 9 a.m. to 1 p.m. will be
1
60.
p.m. Yeah.
Yes or no?
Yeah. 60
Yes,
calls
sir.
exactly.
Yeah, 60
Yeah.
calls, right? Now, next is average. It's an average number. Okay, calls per hour actually should be calls per hour. It's actually total number of calls. Yeah. Now, if you see the average number of calls received by employee from 2 p.m. to 6 p.m. is 5. Then for a single employee, the total call will be total calls between 2 p.m. to 6 p.m. will be how much?
20.
Right? It will
4
be
multiplied by 5.
5
4
into 4,
multiplied by
that
5.
means
Yeah.
20 calls, right?
Yeah.
Do you agree with me?
Yes, sir.
Now, option says average number of calls received by employee in working hour is 10 calls per hour. Let's verify first of all. So tell me, what is the total number of calls in working hour? Working hour is 9 a.m. to 1 p.m. and 2 p.m. to 6 p.m. Right?
Yeah.
So we have to
80.
calculate the average number.
80
So
by
average
8.
80 by 8.
So we have to So 60 plus 20, right?
Yeah.
Total number of calls divided by total number of observations, which is nothing but 4 plus
4.
4, right?
Yeah. 80 by 8.
Yeah, sir.
80
I
by
was
8, that is 10 calls, right?
Correct. Yeah.
First
Per hour.
option was wrong.
Yeah, first option is correct. Okay.
Yeah.
Basically, we have to ignore the lunch break. Okay.
Yeah.
You have to
Yeah.
ignore
That's
the
the catch here.
Yeah, that's the catch.
Yes,
Otherwise,
sir.
you will get the 80 divided by
Yeah.
9.
Less than 10 hours. 10 calls per hour.
Yeah, correct. Now, the correlation coefficient of time and calls received is positive. So, is it correct? Correlation coefficient. Then we don't have observation. We have to here identify the correlation. Okay, when correlation coefficient will be positive, first of all.
If slope is exceeding.
Correct. So see,
Sir,
if you
Yeah,
see the scatter
somehow.
plot, when correlation will be positive, if
When the association is
both are
positive.
increasing, right?
Yeah.
Correct. So here, if you
Okay.
see, when but if you see in this case, the average number of calls received by an employee decreases as the time increases or not?
Yes, it does.
Yes.
It's initially it's a 15, then 5. It's decreasing while
Right.
time is
Okay,
increasing,
okay.
right? That means correlation will be negative,
Negative.
because if one is increasing, another is decreasing, that means correlation is negative, right?
Yes, sir.
Right,
Yeah, okay.
right, sir.
Got it? So C
Right.
is the correct. There is no need of observation, no need to calculate the correlation. Now,
Okay,
the
so
standard
we can like guess, like we are given that between 9 to 15 hours per calls, like
as you can
15,
see,
and after that 5.
yeah, you can see hours is increasing, time is increasing, but average number of calls is decreasing, right?
Yeah, okay, so we can conclude that like एवरेज के लेफ्ट साइड में ज्यादा कॉल है एंड राइट साइड में कम कॉल है, like this. Oh,
So next is standard deviation of the calls received is equal to 0. Is this true?
no.
Why?
No.
Okay, first of all, when standard deviation of the calls will be 0?
When observation are
The
same.
observation are the same. Yeah,
Or
here
I
are
can
different.
say,
All observation
When each observation is equal to mean.
yeah, each observation is equal to
Yeah,
mean.
exactly.
Is this case here? Is this not, right? Mean is varying, correct?
Yeah.
Great. And what about last option?
Slope of trend.
Yes,
Slope
it
is
is
negative, right? That's why we are getting the
Negative correlation.
correlation is
Negative
negative, right? Okay. Is this clear, right?
Sir,
Yes,
I
sir.
think someone's mic are there, so coming background noises.
Okay.
Can you
So, okay, let me mute to all. Okay. So, yeah. So those who have doubt, they can unmute and they can ask. Okay. So I think someone, okay, we have discussed these things. Okay. This all of the things. I think someone asked the question number.
Sir,
Yeah.
the slope of the
Sir,
trend line is negative.
option
Last
4
one,
and
I
5,
don't get
please
it.
repeat it.
This option 4.
Yeah, 4 and 5
Yeah.
also.
Yeah.
Okay, so 4. Okay. First of all, let's concern about 5.
Yeah,
Slope will
only
be
five.
negative, right? Only then you will get the correlation in negative. Yes or no?
Okay, sir. Got it.
This also asking about slope of the trend. See, when you will get the correlation negative, like this, right?
Sir, excuse me, sir. Why the slope is negative, sir? Because I am plotting a graph from the starting. It will be the like that. First hour it will be 10 calls, and the second hour it will be 20. Like that, if you plot average of at the end of the day, the calls will be higher only. Na then it will be positive. Na.
No, but average
No,
in the
but
second half
after,
is less.
yeah,
It's
exactly.
decreasing, right?
After the lunch, number of calls is decreased.
First of all, tell me, okay, correlation coefficient. Okay, just let's discuss this one. See, if you're saying, I'm saying correlation coefficient is negative, right? We got this one.
Yes.
Okay. When you will get the correlation coefficient as a negative?
When one factor is increasing and other factor is decreasing.
That means slope of that line should be negative, right?
Negative. Yeah.
That's all.
Falling. The positive for the
Falling.
coefficient is positive. The best example is buying of a house. When the square feet area increases, your rate also increases.
Rate
That
also
time both are
increases,
going
yes.
up.
Correct.
There is another thing also, like when your age decreases, your energy decrease. Both are decreasing. That time also it is positive. So
Correct.
this we can take as a coefficient when these are positive.
Yeah.
Okay.
And what about
That's the best
standard-
example to think.
Yeah. Like you can take
That
the
means
income and expenditure also. Okay.
Yeah. Demand and supply, income and expenditure.
Yes.
so that means if independent variables and dependent variables are proportional, then only there will be positive association.
Yeah.
No, not always.
No, I think he means whether
Proportional
one is
means
increasing.
if one is increasing, then other will increase.
I got.
and
Yeah.
if one
If
is
you
decreasing, other
if
will
X is increasing, Y is also increasing. Both
Yeah,
are
yeah,
decreasing.
inverse
Then it will
proportion.
be
Inverse proportion is something else. If
negative.
they are inversely proportional, then there will
It's
be
a
negative
negative.
association.
Yes, it's a negative.
Yeah,
Okay.
for negative.
This-
Okay.
This is very
Okay,
clear.
so option number 5, if you see, standard deviation of the calls received is equal to 0, right? So that means what? So if standard deviation is 0, that means all the observations should be same.
Yeah.
Yeah.
Right. That means
Yeah.
average should be equal to the observations, right?
Yeah.
But here is the case? No, right?
Okay. Okay.
Okay. Average is not same here. Okay. Here averages are different.
Yeah.
Okay. Fine.
Okay.
Xi minus x bar is equal to 0.
Yeah. So xi should be equal to x bar.
Yeah.
Yeah. Okay. Any doubt? Any doubt? Anything else?
Sir, I have a doubt.
Sir,
Sir,
I have one doubt, sir.
let me go first, please. Sir, how to find quartiles of group data?
What do you mean by group
Is
data?
that discrete or continuous? What?
No. Is there any question you are talking about?
No, sir.
Okay.
It's
One second.
general doubt.
So group data basically we are okay. So group data means you are talking about in intervals.
Yeah, either intervals or in a frequency table or discrete also.
In a frequency table? No. Okay. Can you repeat? I did not get your point.
Sir,
What you are trying to
I'm saying how to find quartiles of group data. Like we are finding if the data is not grouped by frequency, we are finding the quartiles based on number of observations and
He's saying like for data points
then
along with the
they
frequency
are
given.
grouped. If they are grouped, then how to find quartiles?
Okay. That is something. Okay. I got your point. See, first of all, quartiles for that group data and all. Actually, we have to find the frequency, then cumulative frequency and all. Okay. So for those kind of things, we have different formula and all. Okay. I mean that is we are not going. We are not. I mean this is not in syllabus for in your stats one. Actually, for
Okay,
group
I
data.
understand. Just okay.
Yeah, for that, I got your point. You are taking, suppose there is some 10 to 50, right? There is some frequency for this, let's say 1, for example, okay? Then actually we are calculating the cumulative frequency. Then, I mean, for that formula is something different, then lower bound plus this minus this, okay? So actually that is not in stats 1 course, okay?
Is it absolutely defined quartiles for the continuous data because actual data values are not given? We are just taking a range of
Actually,
intervals.
see, okay, you have the range, right? So I'm
Yeah.
saying that we have to calculate the cumulative frequency and all, okay? So for those kind of things, we have the different formulas, okay?
Not about those things, not about association. I am asking about quartiles of group
Can we
data.
please ask
Like,
related data because we also have
See, Kiran,
just
thing is that,
just
see,
moments.
one second, Kiran. So that is something I'm explaining you. The quartiles for group data and all, we are not covering in stats 1 course.
Yeah, yes, I can understand, but just a clarification that can we find
Yes, we
definitely
can.
for continuous data because
We can find.
We can find
I
it, but
wonder because
it's
we
stats
don't
2
have
course.
actual data.
We can find. It's not like we can't find. We can find, but for that formula and all are different. Okay. Yeah.
Sir, I have a question related with that graph related question, sir. Can you please go to that, sir?
Which graph?
Graph related, there was a question, right? Can you please?
In the mock itself you are
Yes,
talking
yes,
about?
that's right. Yeah.
Okay, let me share my screen.
Mhm.
Which graph?
One graph related between the run rate 15 to 25. Not this, sir.
You joined late?
Yes. I just stopped this one, sir.
This one? Okay, yeah.
Okay. So, sir, the F5 what we gave was the y-axis, right, sir?
Yes, it's a frequency, Fi.
Okay. So if you see for 65 to 70, we will take it as like exact values like 1. What if there is something like, in mid or something, then we can assume that we can take a middle number of 1 between 1 and 2. Can we also do like that, assume things like that? Here it is all perfectly given to the absolute value. Like
So okay. First up, you mean suppose 1.5, 1.6, etc.
Yes, sir.
Okay.
Yes, sir. Yes,
So
sir.
don't worry about that. Scaling should be given to you.
Okay.
There is no need. There is not something like that. You have to assume randomly. Okay. Or
Okay.
else what it can be, this bar for 60 65. Either it can be exact
Yes.
middle of 1 and 2. Then you can say 1.5. I mean, this y-axis scaling will be there. Only then I can find the exact frequency.
Yes. Okay. Thank you, sir. Thank you so much.
Yeah. Okay. Yeah. Is there anybody anything else?
Sir, general doubt.
Yeah.
Sir, tomorrow there will be sessions.
No. So tomorrow there will not be any session. This is the last session for qualifier. Okay. So tomorrow is just for your preparation. Just brush up your concepts and all. Okay. And yeah, that's all something. Okay.
Sir, what about mock 2, sir?
Mock 2 is for practice. Will if you doubt, we can discuss. Or else I will release the solution PDF on the portal itself under that mock test and quizzes. Okay. Basically, mock test for the mock test 1 was the important. Okay. Mock test 2 is for your practice. You can practice if you have time, more time. You can practice. Yes.
Actually, I find mock 2 more difficult than mock 1, sir.
Yeah, actually, okay. Actually, mock 1 is you can find the similar level questions in your exam. As in mock test 1. Okay. Any doubt in mock test 2 you have?
So first question of mock 2.
Okay. So mock test 2 is for your practice. Okay, you can do the practice.
Please show me that formula for cricket and frequency.
Which one? Cricket and?
Frequency question, that sigma square is equal to 1 divided by summation of fi, multiplication of summation of fi into xi minus x by x bar to whole square. Is there only x minus x bar?
Xi minus x bar whole square is there, right? So what? Okay, tell me what the general formula for variance?
Sir, 1 by n
summation of xi minus x bar
x bar whole square.
The
Yes,
thing
sir.
is that we have to just a frequency for all. So we have to multiply with that frequency.
Okay. Only frequency got out, no?
Yes.
Okay.
Fine.
Thank you.
Okay, yeah.
Yes, sir. One request,
Sir,
please.
please share that
Sir, could you can please? Okay.
Yeah, go ahead.
Sir, please
Sir,
share
could
that
you
slide in
please
a chat box.
go through with our formula?
Yes, sir, once. And the important topics which are there for quiz 1.
Okay, for regarding important topics,
Please one by one. Speak one by one.
Okay, please.
Okay, so you
yes,
want
sir,
to
please.
write all the important formula.
You want to say something, then you can say.
Yeah. So, formula for variance and standard deviation, covariation, and correlation, effect of frequency over it.
Okay, so let me write down. Anyway, I don't have any problem. Okay, formulas and all. Okay, so there are very this formula. That is for mean, right? It's aware all of you are about, right? If all are observations, so mean is something what? I have to add the observation divided by number of observations, right? If frequency is given to you, right? Fi is given, okay, for each xi.
Yeah.
Okay. Then mean will be summation of fi into xi divided by summation of xi. Okay. Now, same. What about population variance? So we know population variance is what? Okay, which is denoted as sigma square, which is nothing but 1 upon n summation of I is equal to 1 to n xi minus x bar square. Okay.
Okay.
So frequency is given to you. And frequency is given to you, then it will be sigma square at 1 upon. So basically, what is this? N, number of observations, right? So,
Yeah,
and
right.
if frequency is given to you, that means sum of all the frequency will give me number of observations. So it will be summation of
Sigma
fi,
fi.
summation of I is equal to 1 to n fi into xi minus x bar whole square. Okay. The same for
Okay.
sample variance. Okay.
Okay.
It will be s square as summation of I equal to 1 to n fi xi minus x bar whole square. Okay. So basically this is n minus 1. That means summation of fi minus. Okay.
Okay.
Just we have to understand the concept. See, n represents number of observation. If frequency is given to me, that means summation of all the frequency give me number of observation. That's all. Okay.
Yeah.
And standard deviation will be always be just a square root of. Okay.
Okay. So
And
here I have been using a summation from 1 to n minus 1. That's what I got wrong.
no, summation will be always to n, because we have to consider all the observation in the
Yeah.
denominator only n minus. Okay.
Yeah. That's
And
what I
same
got wrong.
population covariance is nothing but 1 upon n summation of xi minus x bar into yi minus y bar. If frequency is given to you, we have to just multiply. But normally we are not giving the questions related to frequency. Same sample covariance will be 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar yi minus y bar. Okay. Then correlation between x comma y will be summation of I is equal to 1 to n xi minus x bar into yi minus y bar divided by square root of summation of I is equal to 1 to n xi minus x bar square root of summation I is equal to 1 to n yi minus y bar square. This is
Square.
correlation. And point by correlation nothing but absolute point by y bar 1 minus y bar 1 sigma x square root of p naught into p1, where p naught is nothing but n naught divided by n, p1 is nothing but n1 divided by n. Okay. And what else? I think these are the main formulas, right? For median, you are aware, right?
Yeah. That's what I read. Okay.
These are the
So
major
in
formulas.
the covariance, if we are given the frequency, then we have to multiply the x
Don't worry
also
about
and
the
y
okay,
also.
the things you are asking about the hint and all, there will not be any question related to frequency. Okay. Frequency for
Okay.
this covariance and all.
Okay.
Is that all right? Yeah.
Okay. Thank you, sir. Thank you.
So I had a small question in the 15th we discussed today.
Okay. What is that?
Sir, actually B and D values as we chose x and x plus 5. How did we derive the relative frequency for each of them?
Okay, relative frequency. So first
Sir,
of all,
I think the question.
hmm?
No, nothing.
So the 15th
That
question.
donation one question.
Yeah, the
Donation.
First of
donation.
all, this one. Okay.
Yeah.
We know relative frequency is what?
Total frequency upon
Frequency
total frequency.
Total number of observations, right?
Observation.
Observation.
So if I want to know total, that means I can do frequency divided by relative frequency.
Yes.
So total is what? Frequency. I can use any one. Let's use for D. So 45 divided by 0.225.
Yes, sir.
That is 200. So total is 200.
Yes, sir.
So for D, if x, right? So for B, it will be x plus 5. Yes or no?
Yes, sir.
Okay.
One thing. we
Six.
take those relative frequency whose frequencies are given.
Okay, got it, sir. So here we can calculate the x and hence
Yeah,
derive
we
the relative
if
frequency.
you will do 56 divided by 0.28, you will get the same answer. 16 divided by 0.08, you will get the same answer. Anything.
Okay,
Anyway,
Yeah,
total will be the same, right? How total can change? No, right?
got it, sir. Thank you, sir.
Yeah, yeah.
Sir, can you repeat biserial correlation?
In the same question.
No, sir. The formula.
Okay. This one.
Yes, sir.
Okay. So this is the formula for absolute point biserial, which is modulus of y bar naught minus y bar 1 divided by sigma x. So sigma x is the standard deviation, population standard deviation actually, into square root of p naught into p1, where p naught is the proportion of the observations which are coded with 0, and p1 is the proportion of the observations which are coded with 1. That's all. And sigma x, we have to calculate the population standard deviation of the numerical variable. Okay. I mean, that's what you want or something else?
In the question, you had said that we are using sigma x or something else. I didn't catch that.
So I think you could ask at the same time, right? So it's good to ask at the same time. So I told in the lecture video, by mistake, it has been written as small s, okay? So it should be sigma x. That's all.
Sir,
Okay.
sir,
It's a population standard.
correlation coefficients formula are you?
Okay, it's a population standard deviation. Okay, if you want to use the sample standard deviation, then you can replace this sigma with this value, square root of n minus 1 divided by n into small s. Okay, but it's good to go with this one. So you can use in the denominator part population standard deviation. Okay, is this clear?
Yes, sir.
Okay, fine. Yeah. Someone was asking something correlation coefficient here.
Yeah, sir. I am asking.
Yeah.
Sir, what is the formula for correlation coefficient here?
This is the formula.
Yeah. Okay, sir.
Fine.
Sir, okay.
Basically, this is something we are getting covariance divided by standard deviation of x, standard deviation of y. Okay. So thing is that if you are using the population standard deviation in the numerator part, then please use the population standard deviation in the denominator part also. Okay. Only then you will get this formula. Okay. This form. Fine.
Okay.
Yeah. Oh. Okay.
Thank you,
okay.
sir.
So you
Sir,
want?
I have a doubt.
Yeah.
Sir, how do we differentiate between population mean and sample mean? Generally, if it is asked to find the sample
Mean. It's about mean.
variance.
Okay. See. It's about mean. Okay, so you have to just add the observation divided by number of observations. It's asking about variance. Okay, population variance and sample variance. Then you have to divide by n and n minus 1. Not for mean. Mean is summation of all the observations divided by number of observations.
Yeah. So that is okay. But if it is asked to find the sample variance, why can't we use sample mean to find
Okay, what is the
sample?
sample mean? Tell me how will you define the sample mean? Tell me.
Sum of observations by n minus 1.
Okay, is there any
Like
valid formula?
one less than number of
No.
observations.
Tell me, is there any valid formula to calculate the mean like this?
Sample mean. So that is
Okay, first of all,
what
is there any thing related to population mean and sample mean?
no, sir.
No, sir.
I have come across some questions where it was asked about sample mean.
See, its sample means it's written like this. That means it is asking about for that particular data. Okay, for that particular sample data. Mean is just all about summation of all the observations divided by number of observations. Okay, that is something we can calculate the mean. Okay. Okay. Yeah. Okay. So you
please share that slide you have already.
annotated one. Okay. Let me. I'm going to paste on chat box also. Okay. You can find. And also I will upload maybe if it's helpful for you, then I will upload under the mocks, sorry, supplementary content also. Okay.
Okay, sir.
Let me paste on the
Mark
chat
2
box.
also, sir.
Sorry.
Mark 2.
See, mock 2 is for your practice. Okay. So we'll share the solution PDF of mock 2. Okay. You can go through. It's for more practice. There are questions. Those questions are little bit
Yes, sir, we
difficult.
practiced, but for few clarifications, we need the PDF.
Yeah, sure. So we'll upload the PDF under the mock test and quizzes. Okay. Got it? Okay. Is that all right? Yeah, we'll upload the solution PDF for both. As of now, I have pasted the annotated PDF in chat box. You can access from there. Okay. Okay, fine. Yes. No.
Sir, once can you like
Okay, sir.
tell about week 4?
What week 4?
Sir, can you discuss the important topics of week 4?
Correlation coefficient and covariance. The only 3 topics are there: point by serial, correlation, and covariance, correlation, and association between two numbers. And those, I think, we have discussed day before yesterday itself. Okay. The main important topic as a exam point of view, it's you can ignore that part. Which part? It's like point by serial.
It is not going to ask.
You can ignore for qualifier part.
Okay. Thank you, sir. Thank you so much.
Only for I'm saying point by serial, not for others. Okay. Other topic you have to
Why,
prepare.
sir?
Okay.
Why? Okay.
Fine. Okay. Then and you can keep in your mind. See. Okay. Tell me one more thing. It will help you somewhat in your exam. If row relative frequencies or column relative frequencies are same, then association will be there or not?
No association.
No
Both are
association.
different. Okay. By the graph, you can identify. Right? There should be change, right? Significant change, right? Okay.
If we are looking at 100% bar chart, right?
100% stacked bar chart.
Yeah, 100% stacked bar chart.
Correct. Now, yeah, fine. Then you will be able to do some questions. Okay, one more thing. If contingency table is given to you, you can find the things. You can find the association, right?
Row relative frequencies.
Easily, yeah.
You can use any one, row relative frequency or column relative frequency. It's okay.
Yeah,
So in week 1 and week 2, most are the some theoretical things. Okay, those I think you guys will be able to do as I can see in mock test 1. Okay, so don't worry about that level of questions. It will be very easy. Okay, the only thing you have to keep in your mind that conceptual level. That's
What does a 100% bar chart mean? Complete
100%
values.
stacked bar chart.
And what does it refer to?
You just enlarge the data within the 100%.
See, 100% stacked bar chart means suppose I have 2 category. Let's say this is female and this is male. Okay. Suppose female has 2 category. They are going to own a phone. Let's say S and no. Okay. Some of them are saying S. Some of them so. Similarly for male, some male are saying yes. Some male are saying no. So this is 100% stacked bar chart here. So if I will plot 100% stacked bar, 100% means see, I'm not going to with the count. I'm going with the percentage. Means let's say I'm saying let's say 20, let's say 25%. Suppose this portion, this green portion are saying yes. Same for this green portion are saying yes.
Oh, okay, sir. Got it. So 100. Okay, sir.
Yeah, remaining portion will say no. Remaining person say okay. By saying this graph, can you tell me will there be association or not?
No association, sir, because
No association.
It's approximately same, right?
Yeah, proportions are approximately
Yes.
same.
Oh, great.
Got
Great.
it.
Then you will now I have idea you will qualify the exam with the flying colors. Okay. Then
Okay.
thanks all. Okay.
Okay, sir. Good night.
Yes.
Sir, can you write down the intervals of R? Like it will be open bracket or
Okay.
close
See,
bracket or that
just
.25.
day before yesterday session. Okay. I have written
Day
everything when it will
before
be strong
yesterday.
and positive, when it will be strong and negative, strong and everything. Okay. You can prefer that. I have written there. Okay.
At what timing, sir?
Just take your calendar. I think it's a 6 to 8 if I'm not wrong. Okay. You can
So
take.
for
You can find the YouTube link from there. Yeah.
so for the week 4 preparation, are activity questions and graded assignment enough?
Yeah, it's fine.
Okay.
If that be honest, don't worry, there will not be any that too much calculation and all. Okay, you will be able to. The only concept is you to be clear with some when to use. I mean, like while calculating row relative frequency, column relative frequency, and all. Okay.
Okay, so
Yeah. Fine. Okay. Okay then. Thanks all. Okay.
thank you, sir.
All the very
Thank you
best.
so much, sir.
Hope you got the concept. Okay.
Thank you.
All
Thank
the
you
very
so much.
best for your exam.
Okay.
We'll meet after the.
Thank
Yes, sir. Thank
All
you.
the very best.
Okay.
Yes, sir. Thank you, sir.
Okay. Sir.
Good night,
Good
sir.
night, sir. Good night.
Great, sir.
Good night.
Thank you.
Good night.
Good night, sir.
Thank you, sir. Good